Now, let's talk about recycled material in this module. Right. This graph I got it from Umicore, uh, a company dealing with uh, recycle metal products from Europe. Let's say we have portable electronic, handphone, battery, lithium-ion battery, and EMH batteries, hybrid or electrical vehicle. So in this case, we have uh, if we can have a good collection of it, and if we can have a good sorting process, we can send the concentrated ore in abstract to recycling plants in with the smelter technology. They will recover copper, cobalt, nickel, and rare earth metals, and of course we need to produce a clean air as well, while the all the metal products, all the hazardous gas must be taken away from the air. Okay, for aluminum, from the Aluminum Association, 100% of recycled aluminum can end up in another aluminum can as little as 60 days. So, in the United States, the recycling practices has been very good. They use a lot of aluminum, but also they recycle aluminum. And aluminum can has no limit to the number of times it can be recycled. And aluminum is the most recyclable of all materials. It is 4 times more valuable compared to other recycled consumer materials. Throwing away a single aluminum can without recycling is like pouring 6 ounces of gasoline, because uh, to make aluminum is extremely hard and extremely sophisticated, and we need a lot of energy to make aluminum. So it looks like one single aluminum can is like pouring out 6 ounces of gasoline. This table shows the energy consumption for production of primary and secondary metals. Primary metals means that the metal is produced from the ores, while the secondary metals means that the metal is recycled. For example, magnesium, the energy expended for production in primary is about uh, 3072 gigajoule per ton, while the energy that's spent from recovery from scrap is only 10 gigajoule per ton. So it's a massive amount of energy saving on recycling. For aluminum, you can see the energy that we spend for primary production is 253 gigajoule per ton, while for the secondary production or from recycling is only 13 gigajoule per ton. So it's very also massive net energy saving. So what you can see here, sorry, it's not 340 but 240 gigajoule per ton. Uh, and as so on with the nickel, copper, zinc, steel, and lead. Uh, the amount of energy for primary production is much higher compared to the recovery from recycling. So this really need give us insight that we really need to do recycling. A very interesting line here in the table, in the energy expanded from the production of primary metal, you can see the difference of the primary energy between the metals. Magnesium and aluminum is much higher compared to zinc, steel, and lead. To know why, I'm gonna explain in the later module, so keep listening to this video. Okay, so there, of course, in recycled materials, there are a lot of difficulties. The difficulties is actually based on the collection and sorting of the scrap. It also labor intensive, and of course, the metallurgical factors, the physical and chemical factors of it, and also the contamination of the recycled material. So, in the future and now, we also need to apply it. The recyclability of materials and manufactured components it can be increased through the selection or replacement of materials to avoid contamination, improve design for disassembly of obsolete products, a reduction in number of different materials used in the manufactured product. Um, this also it can be so the recyclability of material can be increased. Okay, so in summary, or as a source characteristic, ores and ore bodies are complex association of mineral grains. To enable the selection of suitable processing routes, it is important that those characteristics should be defined. The mineral phases, the proportion of each mineral phase that presents, because most of them in the mineral also there are also gauge material that we don't need, and then also the size and the shapes of mineral grains, the physical and chemical characteristic in the ore and ore body, a variation of characteristic, and the cost of removing of the ore from the ore body, for example the mining.